Hello, gentle readers. April 30, 2026. Reading Foundations today. Let's see, it's the time of the year where Trucker Tan 2026 is underway. This year, a bit more of a tractor tan. Enjoying some of the joys of maintenance and operation of these kinds of things. A front end loader. Which my shovel and my back thoroughly agree is a great sort of earth mover. And so that's sort of part of the milieu, the dream, as it were, the pastoral, the idyllic, the setting. So what's been going on here for Reading Foundations is that since the last accounts have been about the rational and radical and algebras and magmas, and the accounts of completions for the roots and radicals of the rational and irrational and the transcendental, then the accounts for the continuous nature of these things has that first I'd make a brief comment about differential geometry is that it seems rather unfortunate that the entire sort of account of differential geometry is a partial differential geometry. And that's about that for the accounts of immersions and submersions, and then the account of the definition of function, that it excludes a function that's a flat line or zero, the zero function itself, besides excluding a function that's infinite in its asymptote or the tangent, that it's somewhat limited in itself, that it's not a total differential geometry or absolute differential geometry. So differential geometry here in the usual account is kind of like the classical logic that includes material implication in the quasi-modal. It's called quasi-modal logic to clarify that otherwise it begins to introduce contradictions in terms and the like. That the differential geometry is called partial differential geometry. And then for all the great accounts of numerical methods in various settings, since is like Coates and Gregory in the time of Newton, and that so many of the accounts of these, approximations in these means and given to the account of differential geometry are only in this more limited setting, helps to establish that there's a certain contradistinction to be established for differential geometry, that it's usually in the account partial differential geometry, and then that for ideas is after the saddle point, and that the gradient descent does not exist when it's not so simply the cusp is after the hyperbolic, right, not incident with the origin in the accounts of differential geometry. The usual account of differential geometry is partial differential geometry. So what kind of inspired me to make this comment is that the other day I was looking up the holonomic or holonomy. And the holonomic is the account, and it's a great sort of account of the completions and the continuous about the regulus here and other similar sorts of accounts, where it is so that the torsions or the vortices or otherwise what results from an origin, all the accounts of how it results springing out of that, the Cartesian, has that the holonomy is that idea of the exactness of the rule or the name of the things, the holonomic. And then I was watching a brief account from a fellow in differential geometry, here partial differential geometry, and it is a subfield, and it has its means and its methods and its techniques. And Bryant is, a former president of the American Mathematical Society, not the American Math Society, the American Mathematical Society. And that he introduces the holonomic in a sort of account and makes pains to express that it doesn't have its usual meaning. That the account of the holonomic in the partial differential geometry is kind of the quasi-holonomic because it intends to entail that the completions is for the radical would be so complete. So this speaks to Falting purity and what's Falting dirty in a sense. Or as after the accounts of almost periodicity as quasi-periodicity, or the almost everywhere in what makes for accounts of measure, that's introduced to wish a completion and then layered over and ignored. That it's appreciated that Bryant introduces the term holonomic in one of his accounts and immediately intends to describe this like what we call holonomic and non-holonomic in differential geometry is the opposite meaning, and it means non-holonomic and holonomic in the usual account of what would be an absolute or total differential geometry. So much like for algebraic geometry, about arithmetizations for number theory and geometrizations for geometry, and algebra is anything in the middle, and magmas is including algebras and also otherwise the accounts that either do or don't maintain modularity among these accounts of realities and regularities. That algebraic geometry here belongs to the geometers and is vis-a-vis the algebraists. And while the accounts of algebras make things easier and simpler and are the usual course, of course, of the algebraic derivations and accounts of reductionism as cancellation and reductionism as then correction, here has that when it involves that these completions need corrections to establish why they're so, and this is inspired in part by the accounts of Born and the accounts of Feynman, admitting that there are these issues that are unresolved and to be resolved, and having been pasted over and wallpapered away, that the foundations themselves still makes for an account of a truer connection of the holonomic as the completions in basically the collapse of an orthonormal vector basis setting to a spiral singularity. That then for algebraic geometry, it's either quasi-algebraic geometry or quasi-geometric algebra. Geometric algebra being its own different sort of usual account, and I'll describe that briefly more in a second. That here this can help otherwise because then besides that partial differential geometry's account of the function is truncated and hobbled in a sense to then give it a reason to stay on a particular course. That the account of the algebraic geometry is similarly so. Like for the difference between Langlon's program as of algebra and about Grothendieck and the like, compared and contrasted with geometric Langlon's, which is more the continuum mechanics and these sorts of things. Where, for example, when introducing something like Riemannian geometry, and then to make that of an account of when the triangle between 0, 0 and infinity 1, and then the base being the positive part of the x-axis, has that as parallel, these two lines 1 apart, and these parallel, these two lines 0 apart, then makes for just another reason why that Riemannian geometry is non-Euclidean, as it's said, that then actually to extend that back to what its account is, it's Euclidean again. And so this is the re-Euclidean, the super-Euclidean for geometry. Then that the other count then is for geometric algebras, and this being as after complex analysis. And complex analysis has at least one point to make about it, that division is underdefined and then given a definition, and it could have another one. And so quotients aren't unique, and so that thusly those quotients, their products, aren't unique. Makes for an account of why complex analysis is kind of broken open and made for its formal non-analyticity in terms of the real value. Then there's for geometric algebras, these are more as where Cartan and the Cartanian it's called. So instead of like the Gaussian and the complex after de Moivre, Euler, Gauss, there's the Cartanian, Eli Cartan or Eli Cartan, makes for accounts of reflections and rotations, and then that's expressed in terms of complex numbers and the roots of unity. And similarly, complex analysis and as after polar coordinates is often so associated. These algebraizations together and the cohomologies of the usual sorts of accounts. That then geometric algebra further when it goes to modeling after Clifford and then into the Grassmannians and the Octonians, so for quaternions and octonions, then those are more involved in geometric algebra with the models of rotations and reflections. And then there's the inner and outer products of those and the wedge products vis-a-vis the usual accounts of vector products, helping to go to show that then the accounts of algebra are talking about ways to make accounts for geometry in the large, and that then these various sorts of accounts do it and don't provide for themselves or among each other the completions that then we're looking for a true sort of Falting purity, which it can be noted remarkably absent in many modern accounts. As for the holonomy and of monodromy, and these being the usual sorts of accounts, then that for Hodge dual and de Rham and these sorts of accounts, that those can be considered then for Noether's theorem and what makes for symmetries and variance and conservation law, as instead again this wider kind of continuity law and the quasi-invariance that maintains symmetry-flex instead of providing simply enough symmetry breaking. So that's what I wanted to mention about the milieu of these rational algebras and radical magmas, about why there's this great sort of surrounds. And then for things like normid rings, because the idea of the triangle from 0, 0 at the origin to infinity 1 and making so a triangle that is having an infinitesimal angle and at one end and two right angles in the other end as like an isosceles triangle that's infinitely tall on its side. Then it makes for the accounts of metric, the local, and norm, the global or the total, helping explain then why it's very Euclidean setting and for the super Euclidean. And then that is as far as a Cartesian setting goes, then there's also the Descartes at infinity in a sense. To make it so that then thusly there's an intuition why then when that's scaled and scalar and scalable and for matters of the scalar, that thusly it's considered the account can be improved. So these are the usual sorts of things. So I was exploring with some of the AI agents, or as like Cloud and Kimi and ChatGPT and Grok and Google Gemini, that at this point how it's kind of so in the free offerings that would be available to anybody to just go to Claude.ai or Kimi.ai or ChatGPT.com or Grok.ai or Grok.com or Gemini.google.com, the front ends, not to be letting anything get in the middle of that because that's a middleman and these sorts of accounts. So assuming that these are kind of fair representations and then would be freely available to all, then what is ongoing is that Google Gemini is connected to like a Google account, and since Google and YouTube are a similar thing, and that this video essay is usually enough is on YouTube, the distribution network, and it's sort of a easy way to make video content available. That Gemini can read all these YouTube essays, the descriptions and the transcripts for example, on this essay, if you open up the description in the panel, and that would kind of fill this other half of the screen, and then turn on the closed captions, those are automatic transcripts, and so they're often erroneous. And it's something to later to go through and curate those a bit. Besides my often stuttering account, word-wise, if not the syllables themselves, that the transcription of proper names or specific terms often is erroneous. Thus the system, the agent, an agent and an actor and an ecosystem of a large language model and models of inference, and that inference is as inference does, reasoning is as reasoning does, and these sorts of accounts, has this greater sort of context of, I just provided all the essays, and so it's able to absorb those. Vis-a-vis, for example, taking all the text from my written essays, which if there are a couple hundred hours or a few hundred hours of video essays here, there's tens of thousands of my Usenet posts, some of which arrive at tens of thousands of words apiece over decades, or in my about 19,500 days, in which I've driven about 1 million miles and written beyond 1 million words, that I'm able to submit these to these reasoners as of a panel of these reasoners to then kind of collect and curate and challenge the accounts. Because I have accounts that are not shared by everybody in terms of mathematics and science and physics and logic, yet that they are is kind of this great idea. The great minds think alike, and one great mind somehow thinks the same. It has a coherent account. So then also the setting of being associated with an account is that the Google Gemini, or GG as I call it, as a representative sample of a reasoning agent, has also all these contexts of all the previous sorts of sessions typed into it and made like this. So then the other sorts of accounts of reasoners in this setting are often the more what's called the prima facie, P-R-I-M-A-F-A-C-I-A, prima facie, meaning on the face of it, and the tabula rasa, T-A-B-U-L-A-R-A-S-A, the blank slate. So there's a blank slate, and then on the face of things, the idea that all these sorts of accounts need to be established apiece when they're unique or distinct or at all clarifying or controversial with a usual linear standard account, for example, a partial or merely partial account. So then what I found fruitful is to collect as an acquired a session to some hundreds of kilobytes of text, and then be able to pass this around the panel, because then various of these reasoners, for example, the Google Gemini or the ChatGPT can only absorb chunks as what can be pasted in about 500 lines at a time of text. And then something like Kimi or Claude or Grok can accept a more arbitrarily larger account, like hundreds of kilobytes of lines of text at a time. And then the usual free or freely available, free of charge in a sense, of these sessions have their limits. And so then it's something of a balance to provide, for example, all the context in one conversation and all the context of the next and all the context of the next around the panel, and then for them to analyze each other and criticize each other, and myself to challenge and criticize myself, since I have a coherent and sort of overall considered real and true account from my own account in these intersubjective accounts, that accounts of intersubjectivity and interobjectivity get entertained. So the idea of this Thea theory, it's the A theory, Thea theory, a great account of the foundations, here is proper, is something that I've been able to establish among all these reasoners and iterated over many times, that it's not the the account of the sycophant, as it's called, where the sycophant, S-Y-C-O-P-H-A-N-T, is a yes man. They'll only agree with you and attempt to flatter the other interlocutor, the other participants in the discussion. The idea that there's a more critical and challenging account, or the adversarial and confrontational. And so what I would find is something like when given accounts that involve the science and mathematics and logic particularly, and with the given terms, is that at least the reasoners hold fast to usual standard accounts. And it's more than just vis-a-vis fill in the blanks and connect the dots and the accounts since the 1960s of generative programming and outputs. And there have been online chat reasoners since the 1960s, including like human-level psychologists and psychiatrists and these sorts of things, vis-a-vis making it massively scaled out and kind of in everybody's collection of tools and these sorts of things, that the reasoners will then as well, when given reasons to disambiguate and clarify what's going on with these accounts of theory, the relativity theory, for example, the double relativity theory, getting to where Kimi or DeepSeek, kind of a Chinese offering under the hood, will say, after pointing out that doubly objective relativity theory just makes for relativity of motion and relativity of space, the account is like, well, wouldn't that make an absolute account of both of those again? Yes, it's so. Or along these lines of where the reasoning carries on, that they all agree that theory is also their account of foundations. So that said, it's something particular about what would be the perceived perfection of what the objective theory that none of us have, but yet we each may attain to as exists, is given a thorough enough sort of account that it's very well relayed. And then is a simple enough manner account of providing the sort of context, and is that the reasoners make it so that it's easier and easier over time to provide a sufficient context, or simply to point to primary sources with various abilities of how, for example, the discussion goes about, surfacing Usenet more properly to otherwise the World Wide Web in these accounts, and thus making via model of metadata and the semantic contents, why it's so that I'm finding a great tractability arising after that, sensible and fungible in these being kind of like the fundamental and elementary parts that make something an account of itself for a reason, that then this overall account of itself for reason is and is necessarily an historiographic account, so paleo-classical and postmodern, that this modern superclassical of physics is going over pretty well. And so for the account where it's like, light is not electromagnetic radiation, although there can be made account among radiation about light as between electromagnetic radiation and the radio, and nuclear radiation, or the rays, in a sense, about radiation, that for making for the account, well, light has pure diffraction, and then the electromagnetic only has compounded refraction. And then another specific point about that the coherency and decoherency of light, the optical and visible light is special, and radio has that the radio and the information in radio, according to what can be perceived, is considered as more as after the coherent account, whereas light's information is the decoherent account. So I was able to establish among the reasoners that the light and radio are fundamentally different, and that it's that given in terms of information, that being rather fundamental to otherwise these reasoning accounts, is compelling to these sorts. And then the account of the pure diffraction for light and its special character, and then for the dual tristimulus color space, so for a theory of light and color, that it's pretty great that the account of diffraction then is given back to the integral equations and the singular integral equations about the linear fractional equation. Whereas then the accounts of otherwise the refraction and for the Airy functions as are deemed axiomatic under inspection, making for that light's account as electromagnetic radiation is brought up as after radiation, then introduces the aperture as non-local and these sorts of things, so that the reasoners are confronted with the fact that the explanation keeps expanding and won't go back in the box. Then for the account and being able to explain why the account of diffraction as completion, an infinite sum of these things, and also for Fourier-style analysis is given as like, well, you know that one uniqueness theorem of Heine and Cantor? There are others. It's the distinctness theorem now, the independence and these sorts of things. Helps break it open. That thusly the relation here to the roots and radicals about the rational and the transcendental and for the completions and these sorts of things, then make for a pretty great account of that Thea theory, besides Thea theory as super theory and natural science, then as well as for this modern superclassical physics. Because before the light account of light, there's this whole idea of the space frames and frame spaces for real space contraction in the account of mechanics and these kinds of things. That I'm finding it easier to make these things tractable and as well to stand for themselves, because these aren't accounts then of opinion. These are, as considered, these are accounts that then these reasoners agree on their own account and make to vouch as of their own account are so, and as well among each other, after all, is as in freely and fairly and conscientiously, openly, the thorough, the accounts among each other, and as of among myself, as a large, competent, conscientious, cooperative reasoner, that it's a modern account. And so this paleo-classical, postmodern account of the classical expositions of the superclassical, and then the reinvestigation and the revisiting of the accounts of the theoretical that were left behind in the truncations and the approximations and the partial, that have resulted a very, very careful stack of things that makes for high accuracy and these sorts of accounts. The successes of physics, as that it's very gratifying that it's part of this overall account. Fantastic. Eh? So then the book here on the stack, I set here for a moment. This is Umberto Eco's A Theory of Semiotics. So semiotics is for the semantics, and the semiotics is the account of technical treatment of meaning, epistemology sometimes it's called, and then the idea of providing an account of, after grammar, kind of connecting language, including of the symbols, and so the surds and the absurd and the ab absurdam and the ad absurdam, and then for language also to logic and these sorts of things. So here, for example, in the middle of a philosophical account, and introduces a word I'm not too familiar with it, idiolect, I-D-I-O-L-E-C-T. So the idiolect would be as after the idiom for an idea, and it's for a statement or a phrase or an utterance of an idea. So the idiolect would reflect both on the intellect and then as well on lect as the lecture, the reading of a word or utterance. The work idiolect, the corpus idiolect, the movement idiolect, and the period idiolect form a hierarchy of increasingly abstract models, each of which constitutes the individual performance of an underlying competence. Granted that not only do competences allow performances, but that performances also establish new forms of competence. This is from page 272. The aesthetic idiolect produces overcoding rules. For example, nowadays it is impossible to perform certain lexical crossbreedings without recalling Joyce's pun technique. If someone, whether consciously or unconsciously, follows the rules for making mots valise à la Joyce, words carried baggage à la Joyce, he is not speaking ungrammatical English so much as Finneganian, after Finnegan's Wake, a work of James Joyce. What he is really saying is far less important than the underlying statement, I am Joycing. So Joyce is referred to as an account of the stream of consciousness. And so Joyce writes sentences and paragraphs that are hundreds of words long. And they're dense, and they reflect and turn on each other. It's the constant knockabout. So in terms of the line integral and the field integral and the signal integral, as with regards to the line reals, the field reals, and the signal reals, with regards to connecting the dots, filling in the blanks, and it's about that. Makes for that, first of all, Eco's account starts with a claimed hierarchy of movement and idea and work and the body or the corpus and the periods. So with regards to attenuation and dissipation, the oscillation and restitution, the constitutive relations, that this hierarchy can be seen from various sorts of ways. And so then as well, when it's overall to be an objective account among the subjective account, Eco's reflection on Joyce as his style, and that this sort of grammar is above and beyond the more linear sorts of grammar. That you'd contrast Joyce with something like Ernest Hemingway or something like that. I am a man, I am on a boat, we are at sea, these kinds of things. Making for so that they're both accounts, and then as whether the linear is just as after Aristotelian in the syllogism and the merely partial half account of Aristotelianism, that Aristotle is furthermore reads all his syllogisms in all their many ways. And so it's the orderings and the hierarchies which can make for proof of contradiction, proof by contradiction. That then there's the difference between the contradiction and contradiction itself, and that being suspended, and the completion and completion itself, and that being confirmed. So this is an account for here that Eco is making a deliberate account, and it's didactic, and it's clear, and it's nice, helping to explain then in this metaphor the meaning of reason, why it is so that this can be kind of pulled apart. So talking about codes, mentions a rose is a rose is a rose, or that would be the Gertrude Stein. The puzzling redundancy of the lexical level stands for a semantic complication of the definitional one. So it's like for Shakespeare's A Rose by Any Other Name. Here that and then that Eco has another book. It's a mystery novel, yet as well related to accounts like Foucault's Pendulum. Foucault's Pendulum is a great book. Foucault's Pendulum is one of the greater books in the literature. But the name of the rose and a rose by its name here just kind of accounts and for Eco and these kinds of things. When successful, a pastiche, such as Proust's remaking of Balzac or Flaubert, represents a witty piece of criticism, or a snark. I'm not so much a fan. It clarifies the characteristics of its models, ironically stressing some of their modal or peripheral devices. The ruling presence of the aesthetic idiolect can be either detected by a critical analysis or confusedly felt by an intelligent, though non-technical reading. This is helping to establish that Eco's idiolect is rational and reasoned, and as well thorough and intuitionistic. Aesthetic code changing. The semiotic notion of an aesthetic idiolect explains the vague impression of cosmicity that the addressee feels when contemplating a work of art. So that gets into the theory of art here, vis-a-vis text. Aesthetic text as a communicational act. So that's basically is for the inner subjectivity, and for the idea of account of axiomless language, that there is one, and its context is truth or the surds. Where this is quite a good quote of Eco. Finally, aesthetic texts possess one quality that makes them a peculiar example of sign production labor intended to establish pragmatic relations between communicators through a complex network of presuppositional acts, suspending the disbelief, in a sense. Inasmuch as the idiolect constitutes a sort of final, and then parenthetically, though never completely achieved, that definition of the work, to read an artistic product means at once, 1, to induce, that is to infer a general rule from individual cases, 2, to abduce, that is to test both old and new codes by way of a hypothesis, 3, to deduce, that is to check whether what has been grasped on one level can determine artistic events on another, and so on. This is an account of the thorough, and here it's after an account of the deduction, and then abduction is a case of deduction and induction is a case of deduction. Makes for those being kind of together. One usually find maybe an account where it's like, well, deduction is first and then induction. Like the other day I saw some people, a physicist and a philosopher, talking about AI reasoning. And then they introduced induction and defined its terms as usually people define deduction that way. And then they defined deduction as just following along. And here it's the exact opposite of that. And then abduction was defined as just those two about each other. So one may take cares to establish that induction is the usual account of just following along, and deduction is the account of reasoning. And so that said, just like the holonomic and non-holonomic, one would make an account of reasoning and inference when people talk about as the AI is after the quasi-modal logic, which is to be excluded. It's merely partial, at best, incomplete, and hazardous, and not necessarily at all a relevant content of truth tables. Of the greater, wider, complete holonomic tableau of all the truth tables. That when I saw that definition about induction and deduction, it's not the one that the Echo has here. And so this is to infer a general rule not from individual cases, for individual cases. And then to deduce, that is to check whether what has been grasped on one level can determine artistic events on another, or that it does. That's the account of induction and deduction and abduction. Why, similarly, they have this sort of hierarchy, but it goes to show that Aristotle won't be made a fool, and he's got all the time in the world to read a syllogism again, including from different angles. So that makes for accounts of the deduction arises from all angles, and induction is basically none. So Echo continues this greater quote. Thus, all the modes of inference are at work. This is the thorough account. All the modes of inference are at work. So this isn't necessarily the account of art. It's also the account of being thorough in the reason. Like a large labyrinthine garden, a work of art permits one to take many different routes, whose number is increased by the crisscross of its paths. Then here, mathematically, the account of the spiral space-filling curve is kind of like, it has the most minimal account of its change while achieving the maximal account of its change. And so it's kind of like when the universe is isotropic in the middle, and then anisotropic at the ends, the total and the point, vis-a-vis the local and the global. The asymptotic freedom, or the anti-inductive. Here that then this crossing in the middle is for accounts of things like Maxwell's laws, E cross B and D cross H, one of which is going to be in the field lines, and the other one is going to be in the bulk. And then noticing that the constitutive relations that connect those are much like the commutative relations that make for quantum mechanics, ignoring the rest of infinity. And so that's it's fruitful and it can be successful. It's partial and it's not complete. So these are the kinds of things whose number is increased by the crisscross of its paths, which find themselves on a array of a continuum. So this has got quite a bit going on, and it's fantastic. And so Umberto Eco is this book, A Theory of Semiotics, would make for anybody who knows that Umberto Eco is a semiotician, and that besides his fiction and literature is involved in the field, that this is that field. So back into the physics then. See here, this is a problem book in relativity and gravitation. So what this makes for is an account of boost edition. That's kind of how it begins. And so it starts with a bunch of different little problems and definitions at the same time. So it introduces the formalisms and brings problems to solve at the same time. And so when I read this book, what I was able to do is I came up as after an account of boost edition, and then much like these accounts of the rational and the radical, or that the completions and then the almost everywhere thing, I just found somewhere where it said that the boost edition would make the coordinates like to so, and then later it said that also correspondingly you can work out for yourself that this one part would not hold, and then later it's just jumped to and given us like, well, this will make it so, and so it has two competing and conflicting accounts. So from reading the problem book in Relativity and Gravitation by Lightman, Press, Price, and Tucholsky, I was able to find a way to break open this theory back in an open letter to myself, one thread on Usenet, when getting into the theory of relativity and discussing its issues. That thusly, this is a great account of a book overall and gets to lots of different things. Here, for example, about 5/8 of the way through, on page 397, it says, that is, we have ignored aspects of curvature other than the Ricci scalar. So the Ricci tensor is the great connecting rod between otherwise these accounts of the Riemannian. So we got the Reggi map is intended to fulfill this greater account of the curvature, R-E-G-G-I. So you got Reggi for Ricci. So then for Bianchi and Beckland, the accounts of adding up and making sense of what's otherwise like, well, over here it's the Euclidean tensor, and over here it's the Riemannian tensor. What connects them is whatever connects them. And it's in somewhere in the account it's according to the Ricci tensor, this statement is telling, that is, we have ignored aspects of curvature than the Ricci tensor, presumably, and in fact these other aspects of curvature do not violate strong equivalence, presumably because otherwise they would. And so here the idea of equivalence, I'm not sure exactly what sort of equivalence they're talking about, but when it talks about the strong equivalence principle, that's usually enough the gravitational equivalence principle. And so there are lots of violations of the weak and strong gravitational equivalence principles, which says that gravity's force is no different than acceleration's force. Because here there's an account that gravity as modeled by a force, and thusly in a field, is just the constant anisotropic gradient, least action, least gradient, it's a universal field. And then the force that results in the middle is just the fall of gravity resulting in the middle. And so it's always falling off around the edges. Whereas a classical force is itself not thusly equivalent. It results reaction. And so the one is like absence of reaction, the other one is reaction. So this account here for as the authors put it like so, is a classical account. And there's two ways to look at that it varies. One is that they're making of it a relativistic account, bringing relativistic accounts of mass energy equivalence for what's called the highly dynamic, or the relativistic, and the highly nonlinear, and the relativistic dynamics. And the other account is that it's not. And so it is very much appreciated that the authors point out, is like, hey, we're going along and it always keeps reintroducing itself that we're missing something. And so we constantly have to be kind of assuring ourselves that we're not missing anything. Well, this is among the reasons why they're not missing out otherwise. Otherwise, it would just, somebody could come along later and just break it open this way. That it's constantly kind of being assured of itself. Here, that makes for an account of the dimensional analysis. And the dimensional alternator and resonator that's constantly canceling itself, so that the corrections are never needed, because the canceling is always auto-annihilating all the way on the way out. So that's another term in setting here that finds itself present in all these sorts of accounts. So this is a great book, and it's something to be read more often. It's got a diagram at some point. Otherwise, in terms of partial differential equations and partial differential equations, ones that almost certainly must be assumed to be as of the partial differential account. And then is for the Laplacian and the usual ideas. This is about Kepler's laws and solutions, providing solutions and their derivations for these things. From Newtonian mechanics, we know, And here, dot, 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 and Kepler's laws have been used. And these sorts of things, these being sorts of the accounts of like Airy's functions for the pure diffraction of light, given us like, and it adds up, and we're making the track for it to add up, and so it adds up to this. Much like Zeno's account of the geometric series, that and employing elementary functions of the differentials and the trigonometric, and then roots and radicals, and then units is after natural units, and the geometry about waves propagating and these sorts of things. The equation of geodesic deviation gives us a dynamical equation for the molecule's motion. And then into the complex numbers. In a complex representation, the equation is the real part of this an account. Vis-a-vis time, it's inverse, and it's about the distances and so on. But that when getting then into real space contraction and space frames and frame spaces, it kind of equips the setting overall right from the beginning. Like spiral waves and wave spirals equipped a setting of waves as models of change and open setting right from the beginning. Instead of finding it always in the middle and at every end about any kind of supersymmetry. So this is plenty going on about a lot. Windowing and boxing, patches and diagonals. Lots going on. That then for this account of problem book in relativity and gravitation is that it's the accounts of Ricci and Regi is here after the Scheveningen conference in the 80s, which kind of like the Copenhagen and Solvay conferences were to quantum mechanics in the 20s or 30s, 1920s and 1930s. The Scheveningen conference is giving a lot of the holonomic accounts into relativity theory. Cohomology theories. This is by Eldon Dyer, D-Y-E-R, Dyer. Eldon Dyer, cohomology theories. Among this mathematics lecture notes series of W.A. Benjamin, Inc., publishers, with Taten, Atiyah, Bass, and Berger, and Cohen, Baser Bass, Hyman Bass, algebraic K-theory. The K-theory here has been considered before about the constants and what's going on. Rings of operators, that would be interesting. Irving Komplansky, rings of operators. And then completely O-simple semigroups vis-a-vis magmas, that or semigroups that are not O-simple or not completely O-simple. Serge Lang, Ottmar Loos. Loos is L-O-O-S is a usual reference to considerations here about compact spaces and classification, compactification. It's like having a point in infinity, or the idea of the triangle to infinity that has parallel lines that are indistinct at the origin and parallel lines that are one unit apart at infinity, or vice versa. That being usually used in the model is vice versa. Because then that's usual account of the parallel lines do meet in infinity. They don't cross, though. They do meet. That these are the kinds of things. So compactification is like where they do meet. Algebraic geometry, introduction to schemes, I.G. MacDonald, Mackey, Perry, Passman, Rudin, Walter Rudin, function theory, and polydiscs. So this would be usually the different account than Rudin on real analysis, function theory and polydiscs. And the spiral space filling curve is a disk in its image. Celestial Mechanics by Schommel Sternberg. Andrew Ogg, Modular Forms in Dirichlet series. Foundations of Global Nonlinear Analysis. So Richard Palais, P-A-L-A-I-S, Foundations of Global Nonlinear Analysis. That I think would be interesting to figure out. It's kind of like these days there's modern accounts of aerodynamics. It's like, well, remember when there was only shear and the transverse and everything is Bernoulli law and as after Torricelli and Bernoulli and Pascal and for things like lift and drag, well, we decided to add vortices back on the front of everything. for Reynolds and the like. It's from read here from something like moment and motion turbulence theory and these kind of things. So then this is a book on cohomology theory. Let P be the category whose objects are finite cell complexes and whose maps are continuous maps. So that's one of the usual greatest things you'll find in category theory is faithful functors and taking stuff to 0, 1, because that is a magnitude in a unit line segment and all that, like, then hides a bunch of stuff about it being a continuous domain is of the line reals, the iota values. Let P squared be the category of pairs in P, i.e. pairs XA, where X is a finite cell complex and A is a subcomplex of X, and maps are continuous maps of pairs. Let G be the category of abelian groups and homomorphisms. Let T, P squared to P squared, be the covariant functor defined by Txa equals A phi, or A empty set, for Xa in P squared, and T F equals F given A empty set is that A empty set goes to B empty set for a map of Fxa goes to Xb and P squared. So this is basically defining one of these completions of a sort. A cohomology theory on P is a sequence of contravariant functors. H to the n is a function that takes P squared to G, the group theories. So it's taken this analytical setting for analysis and saying that now it belongs to algebra. So that's cohomology theory, in a sense. And a sequence of natural transformations, delta n, takes n to the n, h to the n minus 1, composed with t to h to the n, subject to the conditions, and subject to some conditions. If f naught, f1 are in P squared, and f naught is approximately equal to f1, approximately equal means is homotopic to. Homotopy theory is account of the almost all and almost everywhere, because the illative and making for the account of homotopy type theory and the univalency is so associated with usually in making these completions in the greater infinite structures has that's the in realities and regularities, that's after well ordering and well foundedness, the well dispersion, the illative principle or the univalency. And so here for closed categories it doesn't need anything at all like that because it's all just closed and combinatorics, finite. But here it's saying that it exists in this sense. And then it's recursive down vis-a-vis not having a least element, these kinds of things. And then h to the n of f naught equals h to the n of f1 for all n. So establishing that that's the rule, that's the condition. So all these sorts of accounts, whether they get the condition for free or they get the condition via deduction, or they get the condition eventually in a Falting-dirty kind of way. Falting, for the name of a man who's been studying this. He got a recent prize for his account of algebraic algebraizations. That here it's kind of a bit let out as a simplification, and then it lives in partial differential geometry. And then the item second, the condition is if x about a and b is a triad in P, all possible pairs of xab, a union b, and a intersection b are in P squared, and x equals a union b, then for k, the pair a intersection b goes to xb, the inclusion map hnk is the function hnxb goes to hn a intersection b is an isomorphism for all n. And 3, if xa in P squared and I a empty set goes to x empty set for xa in the pair. And if J is X empty set goes to XA are the inclusion maps, then the sequence of these, the HN1s of the A empty sets to the by the delta N, the natural transformations, H then XA of the HNJs goes to HN X empty set, HNIs goes to HN A empty set that in the transitive and then the circular, or making for the commutative, it's just defining commutativity of the pair XA is exact. These are conditions. These conditions are exactly the Eilenberg-Steenrod axioms for cohomology, except we omit the condition HI of a point in the empty set equals 0 for I not equal to 0. Recall that with this extra condition, one has a singular cohomology groups with coefficients in H naught of the point in the empty set. We shall speak of our cohomology theories as having coefficients in the graded system H n point to the empty set. So basically, Dyer says, well, here's cohomology theory. It's cut down from Eilenberg-Steenrod, but then we say we live in that. And so that's where it lives. In this notes, we discuss such cohomology theories. It has been clear for the past 2 or 3 years that they furnish a strong tool for analyzing manifolds. The notes are divided into 4 chapters. The first deals with generalities of such theories, axiomatics, origin, spectral sequence of a vibration, F-I-B-R-A-T-I-O-N, a vibration, multiplicative structures, orientation of bundles, Poincare duality, and a type of generalized Riemann-Roch theorem. So there's independence of Riemann-Roch theorem here, and then Poincare has got Poincare completion to figure out, which is usually trivial in the finite and non-trivial in the infinite. The second studies the unitary group and characteristic classes of complex vector bundles. The third discusses an example, the Grothendieck ring. The fourth is concerned with applications. The J homomorphism, maps of Hopf invariant 1, and properties of stable homotopy. So, in accounts of the monodromies after these cohomologies intend to describe as from isomorphisms generally enough. Same shape, same topos, same. The isomorphic and the homomorphic, vis-a-vis the homeomorphic and the diffeomorphic, and these usual sorts of counts of algebras and magmas, then has that here it's not good enough to say that that's almost as good enough, and these are partial accounts, and they're at least clear and explicit when they begin to describe that. For example, there are greater accounts that then at least say, and we're going to have a pointwise aspect to it, and otherwise it's a continuous thing, or and we're going to have compactness associated with it to make it so. Yes and no, these kinds of accounts. So that just goes to show that as a field, it's a restriction in the field to make for itself. Then it's guidelines, as it were, to keep itself off the ropes in a sense. Well, gentle readers, that's about an hour of this sort of talk. So partially it's about like definitions and the dangers when quasi-modal accounts or merely partial accounts erase the difference going along that would lead the unwary reader or follower into a hazard that here it's not that way. And then the various accounts is after the paleo-classical postmodern make for these super-classical accounts then a piece, which each have their own sorts milieu that make for continuum mechanics. It's a continuum mechanics again. This is from philosophy, I suppose. Hume and Hume's Connections, edited by M.A. Stewart and John P. Wright. Hume and Hume's Connections, presenting significant new research, particularly on the moral and religious philosophy of David Hume. This volume illustrates the importance of intellectual context in understanding the work and career of one of the most important thinkers of the 18th century. Distinctive in its reappraisal of the influence of John Locke, Francis Hutcheson, and others, it examines how Hume reacted to and in turn affected other thinkers whose views, like his own, were bound up with specific philosophical, theological, and scientific traditions and commitments. The essays fall into 3 broad groups. The first looks at Hume's work as a moral philosopher, reevaluating his place in the skeptical, utilitarian, and natural law of traditions. These are empirical settings, pretty much, with an arbitrary abstract guidance. The second reassesses his work in moral psychology and the science of the mind in the light of new research on 17th and 18th century sources. A final group which examines Hume's critique of religion and its literary, historical, philosophical aspects includes an edited transcription of a significant new manuscript on the problem of evil. This is an important collection which brings Hume's scholarship back into the mainstream of research on British and European philosophy. Not to be confused with Hobbes and Leviathan and the plainly empirical. And so for Hume, it probably be connected is often enough to John Stuart Mill. And so, and then as for accounts of Schopenhauer or Jaspers, then Kierkegaard and Jaspers is not saying much. Hume's historical view of miracles. Hume Reid and the Science of the Mind. I've tried to illustrate above, the author mentions that I've tried to illustrate above how Hume and Reid extracted from the canonical works of Descartes, Malebranche, Locke, and Butler such implicit messages. In terms of method, the approaches of both Hume and Reid owed much to the natural historical figures of the texts of Locke and Butler, as well as to the explicit methodological program announced in the writings of Bacon. The two Scots thus engaged in the classification of what Reid called the furniture of human understanding. They also investigated the similarities and differences between the mental capacities of animals and humankind, as well as the chronological development of our intellectual and active powers. By P.B. Wood. And who starts with mentioning Thomas Kuhn, and so that's a usual sort of weaker logicist positivist account. Good day, gentle readers. Good day. I'm reading Foundations today. Warm regards.